Hi everyone, welcome back. In our last video, we introduced Airflow DAG. Today, we'll take that forward by creating a real-world automation pipeline that combines three powerful tools, Kafka, LangGraph, and Airflow. By the end, we'll understand how a small piece of Python code can simulate support tickets, classify them using an AI agent, and run the whole flow automatically inside Airflow. And if you want the full code, the GitHub link is right there in the description, so feel free to follow along. Let's get started. In this demo, we are simulating something every company deals with, customer support tickets. We'll automatically send fake support tickets into Kafka like my account is locked or billing issue. Pick them using a LangGraph agent, which is basically an AI workflow. Let the agent classify the ticket, route it, and generate a polite reply. And finally, run everything using Airflow DAG. So the process repeats as per schedule and automatically. Simple idea, very powerful workflow. We need to update the default Docker Compose YAML file by adding Kafka and Zookeeper services, and also add pip additional requirements with Kafka, Python, LangGraph, LangChain, OpenAI, and LangChain core, which we need this additionally to run inside the container. This we need to do in the env file as well. You can refer the updated YAML file from the GitHub link below. The first piece of code is the producer. I start by creating Kafka producer and connecting it to the Kafka service. Then I prepare a small list of sample tasks, simple Python dictionaries with an ID, some text, and a priority. The producer sends each ticket into Kafka topic called support tickets. Think of Kafka topics like a message mailboxes. Each ticket is printed out so we know it was successfully produced. So that's the step one. We create fake tickets and drop them into Kafka. Next comes the important part, the AI agent built with LangGraph. I define a structure called ticket state. Think of it like a box that contains everything about a ticket, the ticket text, the priority, the category, the response, and some message history. Then I create small functions. These act like steps in an AI workflow. Classify ticket. This reads text and decide whether the issue is about authentication, billing, a feature request, or something general. It's just simple keyword checking. Route ticket. Next, the workflow decides where the ticket should go. High priority tickets go to an urgent queue, billing issue go to the billing system, and so on. Generate response. Finally, based on the category, the agent creates a small automated reply. Nothing fancy, just a predefined dictionary of responses. After defining these steps, I plug them into LangGraph using StateGraph. I connect these steps together, classify, route, and respond, and that's it. We have built a simple but intelligent workflow. Now that we have sent the tickets, we need to receive them. I have created a Kafka consumer that listens to the same support ticket topic. Whenever a message arrives, we pass it through the LangGraph agent we just built. So the consumer prints the ticket being processed, runs the AI workflow, and show the final classification, routing decision, and response. This is where everything comes together. Kafka and LangGraph equals automated support ticket handling. The last part of this code sets up an Airflow DAG. A DAG is basically a schedule. It defines what text to run and in what order. Here we have produce tickets. This calls the producer function, and then the process tickets. This calls the consumer and agent, and we link them like this: produce tickets followed by process tickets, meaning first produce and then process. We also set the DAG to run every hour, so even if we don't trigger it manually, the Airflow will take care of it automatically. At the bottom, there is a simple section that lets you test the whole pipeline without Airflow. Just to run the script directly, and it will produce tickets, process tickets with LangGraph, and print the results. Perfect for local testing. We need to copy this file under the Airflow DAG folder. Then we need to run Docker Compose. You can see the Kafka and Zookeeper images are added in the container. Once you see everything is in green, you are good to go. Hit localhost 8080 and then move to DAG. You can see the DAG named Kafka LangGraph pipeline is already available. Also, you can observe the DAG has two tasks, produce task and process tickets. Let us run this manually for demo purpose, although you can see it is scheduled to run every 1 hour. Now the task will run one after another and both the tasks are completed successfully. If you double click on the produce tickets, you can see Kafka has produced 4 tickets as programmed. For the next task, that is process ticket, LangGraph has processed all 4 tickets. For each ticket, it has done ticket classification. Based on the classification, it has routed the ticket accordingly. Also, a response and final result generated. And that's it. We just built a small, realistic, and beginner friendly workflow that simulates customer support automation using Kafka for message streaming, LangGraph for AI based logic, and Airflow for scheduling and orchestration. If you learned something new today, hit the like button, drop a comment, and don't forget to subscribe for more practical AI and data engineering tutorials. Thanks for watching. I'll see you in the next video.